Hello guys, good morning, good evening, good afternoon. So today also we continuing the Docker when it's come to how to use in the multi-stage context. Actually, so far we read I think so one Docker file, but I think yeah. So that's why that is the progress we so far did creating or writing the one Docker file. But from today onwards, we are going to divide the Docker file into two parts or more than two parts. Like that's why we call the multi-stage Docker images or multi-stage build. So we will explore and we will start around 4:30. Okay, so yeah, and again, welcome to everyone. This Saturday morning live session. Thank you. So guys, we'll start. I think it's 4:30 am, and we will start today the multi-stage Docker build and multi-stage image build. Okay, let's start.
We are at day 26 of our complete DevOps course, and this video is going to be a both practical as well as a theory class. And this is very, very important because I am going to explain you some production issues with Docker, or whenever interviewer asks you what are some of the practical problems that you have faced with Docker or containers and how did you solve them. So many people are asking me this kind of interview based scenario sessions, so that is one of the main reasons I choose to talk about this topic today. So what we are going to learn on a very high level is, one, we are going to understand the concept of multi-stage Docker builds. And the second thing that we are going to cover is distroless images. Okay, so there is a very close relation between both of them. That means by using distroless images, you can improve the efficiency, or you can get maximum benefit of multi-stage Docker builds. Now, many you by using distroless images, you can improve the efficiency, or you can get maximum benefit of multi-stage Docker builds. Now, many people must have heard about this terminology called multi. You can improve the efficiency, or you can get maximum benefit of multi-stage Docker builds. Now, many people must have heard about this terminology called multi-stage Docker builds, but you might not have heard about distroless images. So don't worry, we will try to cover both of them practically as well as theoretically. So watch the video till the end so that you get all the useful information. And like always, I put all of this content into the GitHub repository as well. So you can get the details of GitHub repository so that you can try these things practically at your end. Now, firstly, we should understand what is the concept of multi-stage Docker builds. So before that, let's try to see what is the usual process, okay, that we follow to write a, let's take an example, to write a calculator application. Okay, so your task is to uh, like execute a calculator application as a Docker container. Okay, so assume this is a Python application. Now what will be your steps? So the steps would be, to start with, firstly I will use a base image. Let me use Ubuntu in this case. Okay. And after that, what I'll do is, if required, I'll set the work directory. If not required, I'll skip it. And after that, I will install the dependencies. Like in this case, firstly, I have to start with installing the Python. So I'll say run apt and install Python. Then I will install probably pip. Then I'll install, let's say if it is slightly advanced calculator and require some Python modules or Python packages. So I'll install 1, 2, 3 Python packages that are required. And then finally, what I'll do is once this binary is built, okay, and I'll try to build this egg file or whatever is PYC file or something, and then I'll execute that. Okay, so as part of the CMD. So this will be a steps on a very high level, right? Slash app, for example. So this will be the steps on a very high level. Now, while this is a very good Docker file that you have written, okay, so there is a problem with this Docker file that you have to understand. Okay, to start with, if you are a beginner, then yes, you have written a very good Docker file. But the problem is that even for this basic calculator application, or it can be a complicated application as well, that your organization is using, you only require Python runtime to execute this application, right? Because it's a Python runtime to execute this application is using basic calculator application, or it can be a complicated application as well, that your organization is using. You only require Python runtime to execute this application. Right? Calculator application, or it can be a complicated application as well, that your organization is using. You only require Python runtime to execute this application, right? Because it's a Python application, you will require a Python runtime to run this application. If it was a Java application, you would only require Java runtime. But if you look at the Docker image that you have created, it has 100 other things. It has a Ubuntu base image. Like this Ubuntu base image will come with a lot of Ubuntu system dependencies, and it will come with apt packages. It will come with apt repositories, right? So it has a lot of overload on your simple Docker image that you want as output. End of the day, you just want to run this calculator application, and that calculator application only requires Python runtime, not even the applications that you have installed as part of these stages. These are only required to build your application, right? So these are two different stages. Build is different, running your application is required. To build your calculator application, end of the day, you just want to run this calculator application, and that calculator application only requires Python runtime. Not even calculator application, and that calculator application only requires Python runtime. Not even the applications that you have installed as part of these stages. These are only required to build your application, right? So these are two different stages. Build is different, running your application is required. To build your application, let's say you are building a Java application. So to build your Java application, you might want hundred of sorry Java libraries that you want to put in your pom.xml, or you might require a lot of jar files while building your Java application. But to execute your Java application, what you'll require, you only require JRE, Java runtime, plus your Java binary. It can be a jar file of libraries that you want to put in your pom.xml, or you might require a lot of jar files while building your Java application. But to execute your Java application, what you'll require, you only require JRE, Java runtime, plus your Java binary. It can be a jar file, war file, or ER file. So those are the only things that you'll require. Right? Jar file, war file, or ER file. So those are the only things that you'll require. Right? You might require a lot of jar files while building your Java application. But to execute your Java application, what you'll require, you only require JRE, Java runtime, plus your Java binary. It can be a jar file, war file, or ER file. So those are the only things that you'll require, right? So why you need a base image, that is a Ubuntu base image that is coming with a lot of overload. But you might say that, oh, okay, I require a Ubuntu base image because I want to install all of these Python dependencies, and it is very easy to install them using Ubuntu. Probably I can also use CentOS or any other thing. So for this problem, to solve this problem, what Docker said is, oh, okay, let me introduce a new concept, and this concept is called as multi-stage builds. Okay. Ubuntu. I want to install all of these Python dependencies, and it is very easy to install them using Ubuntu. Probably I can also use CentOS or any other thing. So for this problem, to solve this problem, what Docker said is, oh, okay, let me introduce a new concept, and this concept is called as multi-stage builds. Now, what you will do as part of multi-stage builds is you will split your you will split your Docker file, okay, into two parts. Now, this can be multiple parts, but if we go back to our example, I'll start with two parts. Then I'll explain you how it can be multiple parts as well. But for first reference, let us start with just two parts. So in the first part, what I'll do is I'll do the same thing from Ubuntu. Okay. Then I'll use the run command to install all of the dependency packages. Let's say 1, 2, 3, 4, 5. Okay. Then what I'll do is I will execute this as CMD. Okay. This was the initial process. But here, what I'll do is in the multi-stage build, I will not have this step. Okay. So instead of executing the command here itself, or instead of executing the entry point here itself, what I will do is I will take the binary from this Docker image or from this Docker file into this specific Docker file. So you can consider it as stage 1 and this as stage 2. So you'll write both the stage 1 and stage 2 as part of the same Docker file. Okay. So this this will remain as both stage 1 and this as stage 2. So you'll write both the stage 1 and stage 2 as part of the same Docker file. Okay, so this will remain as only one single Docker file. But what you will do is you will have two from statements. So here Docker stage 2 as part of the same Docker file. Okay, so this will remain as only one single Docker file. But what you will do is you will have two from statements. So here you will say from Ubuntu, and here basically I will choose a very minimal image. Okay, so it can be a image that I'm statements. So here you will say from Ubuntu, and here basically I will choose a very minimal image. Okay, so it can be an image that has just Python runtime. Okay, or it can be an image that has just Java runtime. Okay, so you'll find these images. I'll show you how to find these images. Or here you can also choose a distroless image. So distroless image, I'll talk in next 2 minutes. But before that, you understand that here you are using a from Ubuntu image because it is very easy to install packages or is it is very easy to because but before that you understand that here you are using a from Ubuntu image because it is very easy to install packages or it is very easy to get all the dependencies that are required for building your application on the Ubuntu image. For example, Ubuntu image by default has curl. Ubuntu image by default has wget. Ubuntu image by default has a lot of things that are required for building your applications. But these Python runtime or this Java runtime, they are specifically Python images. They might not have curl. Okay, so you don't have to install curl. They are building your applications. But these Python runtime or this Java runtime, they are specifically Python images. They might not have curl. Okay, so you don't have to install curl because curl was only required during your build process, because you are executing during your execution stage. You don't require curl because you only have to run. So this specific stage 2 will only have from the Python runtime environment, that is Python runtime base image, plus you will copy the artifact binary from this step to here. What you will do is simply you will use the same copy command, but you will say hyphen hyphen from, and you will say here you will mention enter from Ubuntu as build, for example. You can create an alias from build. Okay, this has again a syntax, I'll show you. But here from sorry, copy from your base image, and then you will have the image from stage 1 to stage 2. Here you can simply say cmd slash app. So here you will not have entry point or CMD, but in the final stage you will have the entry point or CMD. So what is the advantage with this is you have reduced your image size significantly. All this content will not be in your final image. Okay, so this will be only part of your build image, and this will be your final image. Okay, so if you look at your final image, it will have only Python runtime. It will have only the binary that you have built in your build stage, and just the executable. Now this might look very simple to you, but let's take another example that will clear cut explain you what is the fundamental advantage of distroless multi-stage Docker builds. So let's take a complicated application that has front end, that has back end, and that has some DB related stuff. So in such cases, what you will do is you will effectively choose one base image first, again from Ubuntu, and then you will start installing all of the packages that are required for your. So this is a three-tier architecture application. Okay, so for this three-tier architecture application, front end is React, for example, back end is Java, Spring Boot, and then you have some DB related things, for example, MySQL. Okay, So in this Docker image, you have to install all of these things. Firstly, you will choose Ubuntu base image. Now, why can't you this? You have backend is Java, Spring Boot, and then you have some DB related things. For example, MySQL. Okay. So in this Docker image, you have to install all of these things. Firstly, you will choose Ubuntu base image. Now, why can't you directly choose Java runtime here itself? Anyone can answer this one? You cannot choose Java runtime directly here itself, because if you directly choose Java runtime base image, Java runtime image as a base image, or OpenJDK as base image, okay, or Python as your base image, the problem would be you have to install hell lot of things. Okay, your Docker image will become very, very complicated. And that was the steps people or DevOps engineer used to do 3 years, 4 years ago. But with the advancement of this multi-stage Docker build, what you are simply doing is base image, you choose a very rich base image. What do I mean by very rich base image? A base image that has all the dependencies. Okay, you are not even worried if this base image is 1 GB or 2 GB. Okay, the reason for that is base image will be removed, and finally the Docker image that you are creating will only have the last stage, that is the final stage. All the dependencies. Okay, you are not even worried if this base image is 1 GB or 2 GB. Okay, the reason for that is base image will be removed, and finally the Docker image that you are creating will only have the last stage, that is the final stage. Okay, okay, you are not even worried if this base image is 1 GB or 2 GB. Okay, the reason for that is base image will be removed, and finally the Docker image that you are creating will only have the last stage, that is the final stage. Okay, so to go back to the example, let's say if we are not using this multi-stage Docker build concept, okay, for example, only have the last stage, that is the final stage. Okay, so to go back to the example, let's say if we are not using this multi-stage Docker build concept, okay, for example, if you are not using this concept, what you have to do is firstly you'll start with from Ubuntu, then you will install all the dependencies regarding Java, you will install all the dependencies regarding React, you will install all the dependencies regarding MySQL, then you will build your Java application, okay, then probably you'll build your front end, and as part of your entry point you will execute a combined application, right? So it can be a ER file, for example slash app dot EAR. So this will be your output that you are execute. For install all the dependencies regarding Java, you will install all the dependencies regarding React, you will install all the dependencies regarding MySQL, then you will build your Java application, okay, then probably you build your front end, and as part of your entry point you will execute a combined application, right? So it can be a ER file, for example slash app dot EAR. So this will be your output that you are execute. The problem here would be this Docker image will go crazy, so it can even go up to 1.5 GB or 1 GB size. Okay, so why did it go to 1 GB? Because you haven't used the concept of multi-stage Docker build, and this so it will be in these steps, right? So the first thing, when you download the base image, that is Ubuntu, probably it can be 400 MB. Okay. On top of that, you have installed Java, so it can be some 50 MB. On top of it, you have installed the React related things. Again, it can be some 100 MB. On top of it, you install MySQL, then again it can be 100 MB. So you have piled up all of these things on your base image, because of which it went to 1 GB. So using this multi-stage Docker build concept, you can avoid this problem, because in the final stage, what I'll only do is I'll say, because the final image is just a Java runtime environment, I'll say from OpenJDK. Yeah, from OpenJDK colon 11 or 12 or latest, whatever you want to use, the version of the image. So from OpenJDK, just copy the hyphen from the base image. From here we can say Ubuntu as build. Okay, so from Ubuntu as build, you will create an alias for it. So here you will say from build, you will copy this specific ER file, and finally as part of the entry point or CMD, what you will do is you will just execute this specific app.ear. So what will be the final image size? If this OpenJDK is 100 MB and this binary, because this is just a binary, it should not be more than some 50 MB or something. Again, this will depending upon your size. Application size, but hardly it will be some 50 MB. So your final image size will only be 150 MB. Okay, so you have reduced from 1 GB to 150 MB. This is the advantage of multi-stage Docker build. Now this can be of multiple steps as well. Okay, so here I just took example of one stage, but you can increase the stages depending upon your application. So in some scenarios, for some people, this Docker multi-stage build, I'll show you practical example as well. Don't worry. But here it can be of 2 to 3 stages. Okay, so in the first stage, you might only focus on building your front end. Second stage, you might only focus on building your back end. And in the final stage, what you will do is you will only get the dependencies from front end stage, back end stage, and as part of your CMD, you will just execute it. Okay. So if somebody asks you what are the number of stages that can be in a multi-stage Docker build, the answer is countless. Stage was show you practical example as well. Don't worry. But here it can be of 2 to 3 stages. Okay. So in the first stage, you might only focus on building your front end. Second stage, you might only focus on building your backend. And in the final stage, what you will do is you will only get the dependencies from front end stage, back end stage, and as part of your CMD, you will just execute it. Okay. So if somebody asks you what are the number of CMDs from front end stage, back end stage, and as part of your CMD, you will just execute it. Okay. Okay. So if somebody asks you what are the number of stages that can be in a multi-stage Docker build, the answer is countless. So you can create n number of stages, but there will be only number of stages that can be in a multi-stage Docker build. The answer is countless. So you can create n number of stages, but there will be only one final stage, which will be a minimalistic image. Okay, so it has to be a minimalistic image, because by choosing a minimalistic image, you will get the advantage of your Docker multi-stage build. So here, okay, so it has to be a minimalistic image, because only the number of stages that can be in a multi-stage Docker build. The answer is countless. So you can create n number of stages, but there will be only one final stage, which will be a minimalistic image. Okay, which will be a minimalistic image. Okay, so it has to be a minimalistic image, because by choosing a minimalistic image, you will get the advantage of your Docker multi-stage build. So here, okay, so it has to be a minimalistic image, because by choosing a minimalistic image, you will get the advantage of your Docker multi-stage build. So here I'll introduce you to distroless images. Okay. So now we have set the ground very well for you to understand what is a distroless Docker image. Many people find this very complicated topic. I don't even understand why people find it difficult, because I looked into some Google groups, Google forums, the ones that I've subscribed to, or the CNCF Slack channels, people ask a lot of questions on distress images, but this concept of distress images is very, very simple. Okay, so don't get confused. Distress image is basically a very minimalistic image. Okay, so it is a very minimalistic image that will hardly have any packages. Okay, so for example, like I told you, if you choose a Python distress image, now where will you, that will hardly have any packages. Okay, so for example, like I told you, if you choose a Python distress image, now where will you get this distress images? Don't worry, I'll show you that as well. So if you want to choose a Python distress image, so this Python distress image will only have Python runtime. Like in the previous example, I explained you, I will choose a open image. So this Python distress image will only have Python runtime. Like in the previous example, I explained you, I will choose a OpenJDK distress image. Like I told you, this will be only 100 MB because it only has OpenJDK. Okay, now there will be another kind of distress images that will not even have Python runtime. For example, if you take example kind of distress images, OpenJDK. Okay, now there will be another kind of distress image. That will not even have Python runtime. For example,
So as I mentioned, we started today with multi-stage Docker. So it's nothing at so far. Just we did create our Docker file as a single stage. There are no split. But to make more efficiency or like to reduce the Docker file sizes, like for example, if you have 1 or 2 GB, you can still reduce this Docker file Docker image file size as around 200 MB or even 100 MB when we work with multi-stage build Docker images. So here we can split particular Docker file into two or more than two parts. So there are the first our base image, maybe we have like 1 or 2 GB, but our final on the final stage on the final in the second stage of the final stage we have a very simple image, like it's only have the runtime related details, so runtime related file only. So we will explore further the distroless image. It's also similar, the big final stage, or we use the final stage this kind of image. So we will explore after small break. Thank you. Again, if you have any question, please put in the chat. I will reply. Thank you. Sorry, so guys, we will start because it's almost 5:40 plus 5:41. We'll start and maybe we will continue around 6:15 or 6:20. Okay, thank you.
Example, if you take only 100 MB because it only has OpenJDK. Okay, now there will be another kind of distroless images that will not even have Python runtime. For example, if you take example of a Golang application. Golang application is a statically on. Now there will be another kind of distroless images that will not even have Python runtime. For example, if you take example of a Golang application. Golang application is a statically typed application. Okay, so these statically typed applications, they don't even require runtimes. Okay, so you don't require a Go runtime for executing Go application. Okay, don't require statically typed applications. They don't even require runtimes. Okay, so you don't require a Go runtime for executing Go application. Okay, so because of which you will reduce your Docker image to typically like some 10 MB or 15 MB size. Okay, and this will be our practical as well. So the practical example that I'm going to show you, that is intentionally on Go language, because I want to show you the advantage of distroless images plus multi-stage Docker build. Okay, so what is a distroless image? A distroless image is a very minimalistic or lightweight Docker image that will have only the runtime environments. Okay, so if you are choosing a distroless image called as Python distroless image, okay, this Python distroless image, even if you try to perform some basic shell commands like, for example, I'm telling you, if you try to use a shell command called find, you'll get error saying that find executable is not found. You will try to use some basic shell command like curl or wget, or even in some cases you'll not be able to perform commands like ls, because the main idea is to just have a runtime environment, or just to have your final Docker build that only has a Python runtime, and the only purpose of this environment is to just execute the slash app or Python application, or just to have your final Docker build that only has a Python runtime, and the only purpose of this environment is to just execute the slash app or Python application. So one biggest advantage that you would get from distroless images is the security. Okay. So other than reducing your container image size, you will have highest security with distroless images. So this size, okay, or runtime, and the only purpose of this environment is to just execute the slash app or Python application. So one biggest advantage that you would get from distroless images is the security. Okay. So other than reducing your container image size, you will have highest security with distroless images. So this is something that you can answer in your interview as well. When someone asks you what is one of the production issue that you faced with Docker containers and how did you solve it, you can say that previously we were using Ubuntu base images, or previously we were using, even in the final stage, we were using Ubuntu images or Python runtime or any other runtime images which were exposed to some kind of vulnerabilities by hackers, or people usually find some kind of issues with these images. So we move to distroless images. If you are using a Python application, for example, in your organization, you can say we move to a Python distroless image which only had Python runtime, and because of which, like, it even did not have some basic packages like find, ls, wget, curl. So it was providing us highest level of security, and we, after implementing distroless images, we are safe to say that our applications are not exposed to any OS or operating system related vulnerabilities. Okay. And let's say you are using applications like Go language, then you have even highest level of advantage using distroless images, because you don't even need a runtime. So this distroless image to any OS or operating system related vulnerabilities. Okay. And let's say you are using applications like Go language, then you have even highest level of advantage using distroless images, because you don't even need a runtime. So this distroless images are like, you can literally say they are 99% of times not exposed to vulnerabilities. Okay, if you are using applications like Go language, if you're using applications like Python, at least they have Python runtime. So there is a very little chance. Okay, little means like, very, very little chance of exposing to security threats. Now, I hope you understood the concept of this distroless images and whatever I was talking. Now, what I will do is I will first show you the example that we are going to discuss today. Okay, so like I always do, so this is my GitHub repository. This is my GitHub organization. Let me increase the font. And I have a repository called Docker 0 to Hero, right? So you can go to this repository. All the Docker classes we are trying to learn using the same repository. and in the future classes also where I'll talk about networking, I'll talk about volumes. I have already prepared the content and it is ready. So if you go to examples folder here, you have something called as Golang multi-stage Docker build. So why did I choose Golang explicitly? Like I told you, you can understand the biggest advantage of multi-stage Docker builds with programming languages or the applications like Golang, because they are statically typed and they don't even require the Golang runtime. So you can replace the same application, like you can write a Python calculator application and you can try, and even you will find the advantage of distress images. Don't worry. Oh, sorry, I was not sharing my screen. So let me stop sharing here and show you the screen. Sorry for that. I can stop sharing here. Just give me a moment. Stop share and let me share this one. Where is this? Yep. So share. Yeah. So if I go back, I was just explaining about this repository here. That is Docker zero to hero. So you can go to my GitHub organization and you can find this repository called Docker zero to hero. And in this repository, I have a folder called example where I am going to explain or demonstrate the multi-stage Docker build using Golang multi-stage Docker build. Okay, so reason why I choose Golang is I already explained you. I was sharing the wrong window, but I hope you understood the concept that I was explaining. So let me clone this repository. I already cloned this repository to be honest. And now I will execute this Docker file. I'll show what is this calculator application and let us see the difference by using multi-stage Docker build and by not using multi-stage Docker build. Okay, so that it will be clearly evident and you will see a drastic advantage of 100 times less image. Okay, so the size of image that I'm going to show you will go by 100 times by using the concept of multi-stage Docker build. Yeah, so we are all excited. Let us go to examples folder. let us go to Golang multi-stage Docker build. ls, and now this is the calculator application. Oh, sorry. Yeah, so ls, and now this is the calculator application. Oh, sorry. Yeah, so this is the calculator function that I'm going to run. Simply you can do go run calculator.go, and you will see what I'm going to show you. So this is a very basic application which says provide the inputs for the calculation. Like if I say 2 into 2 times of 100, so it will give me 200. Like if I say 5 divided by 2, so it will give me the output. Okay, so this is the calculator function that I'm going to show you now. So it will give me the output. Okay, so this is the calculator function that I'm going to show you now. We will containerize this, and what we will do is we will execute the container. So let us firstly start with Docker file without multi-stage. Okay, so go to this folder that says Docker file without multi-stage, and it will have something called as a Docker file. So what are the steps? Says Docker file without multi-stage, and it will have something called as a Docker file. So what are the steps? I just have a base image that is from Ubuntu. I call this as build. You can ignore just for keeping in sync with the multi-stage build. I just created an alias. But from Ubuntu, what I did is I installed Go language, and then I enabled this Go modules as off. Don't worry about it. Then I copied the source code that is calculator.go into this specific thing and find language. And then I enabled this Go modules as off. Don't worry about it. Then I copied the source code that is calculator.go into this specific thing. And finally, I'm running the Go build and building the binary, and I'm executing the binary as part of the entry point. Okay. So if you're not familiar with Go language, don't worry. Your steps will be replaced here. So if you are a Python application, this copy command will be the same, the calculator.go, or you can also use the Django application that I explained in the previous class. This will be the same. This will be removed. You only have to modify this specific command. Okay, or you can directly put your .py in your entry point itself. But I will recommend you to create a .pyc or a egg file and execute that egg. Now, what I am doing here is I am copying the source code. I am executing, I'm building the Golang binary, and I'm running the Go runtime or the Go binary. But as I told you like 15 minutes back, to actually run this, I don't require the source code. I don't require Go language. I don't even require the binary. Sorry, I require the binary, but I don't require the source code. I don't require the packages that I have installed. So let us see what will be the image size here. Okay. So let me build this one. Let me go to this folder and let me build the calculator application. So go docker build -t. Let us provide a tag and let us call this as uh, simple calculator and dot. Let us see what will be the image size of it. So what it is initially doing, it is pulling the Ubuntu image, then it installs all of the things. It is done. Let us see Docker images. I have a lot of images on this laptop, so just I'll do head -5. So you will see the latest 5 images that are built. So simple calculator. What is the size of it? 861 MB. So do you really think for this basic calculator application, do I need this much size of Docker image? Like you can say that, oh, Abhishek, you can this. So simple calculator, what is the size of it? 861 MB. So do you really think for this basic calculator application, do I need this much size of Docker image? Like you can say that, oh, Abhishek, you can reduce the Docker image size by simply using, like, instead of using Ubuntu, you can probably use something called as a UBI image. Red Hat provides a UBI image, which is lighter, UBI minimal, for example. Okay, so this UBI minimal, you can say that it is lighter than Ubuntu, why don't you use it? Or you can also say you can simply use Golang, right? Not distroless, but you can directly use a Golang image that Go is providing. You can do all of those things. Even after that, your image will not come less than 500 MB or 400 MB or 300 MB. Now what I'm going to show you is the concept of multi-stage build and distroless images, by which you will be shocked to see the size of the final image that I am going to create. Can anybody guess here? Like, it will be great if somebody can give a right guess. What will be, like the image that we have built is 861 MB. Now, using the concept of multi-stage Docker builds, what will be the size of image that we are going to create? Any guesses? Let us see if somebody will guess right in the comment section. So what I'm doing here, like I told you, I have split this into two stages. One is the base image stage, and one is here starts the magic of multi-stage build. This is the final stage. Okay, so I have split the Docker file into two stages. This is stage one, and this is stage two. If you clearly see in stage one, I don't have entry point or I don't have CMD, right? So what I've done is stage one is only dedicated to the build steps, where I've used the Ubuntu base image, then I have used this one here, like I have downloaded the Golang, then I have copied the source code. Finally, I created the binary. And in the final stage, I am using a special image called Scratch. So this is minimalistic distroless image that we have today. Okay. So there can be any new things that I'm not aware of, but as far as my knowledge is concerned, Scratch is the minimalistic distroless image that we have till date. So that's why to show you the biggest advantage of distroless images plus multi-stage Docker builds, I've used Scratch. So if you try to use the same thing for your Python application, it will fail because your Python application requires Python runtime, but Go language applications will not need Go runtime. So if you decide to use Scratch image, then what you need to do additionally is you have to install Python on this Scratch image. So instead of Scratch, if you are using Python or Java applications, you can choose Python or Java distroless images. I'll show you how to install Python on this Scratch image. So instead of Scratch, if you are using Python or Java applications, you can choose Python or Java distroless images. I'll show you how to find them. Don't worry. So from scratch, if you're using Go language application, use Scratch. From scratch, just copy the binary. So as I told you, this is the syntax from hyphen hyphen from build. That means I'm copying the binary from the build stage that we have created here, and I'm just executing it as part of the entry point. Let us try to execute this and see what will be the size. So I'm just executing this and see what will be the size. So Docker build. Now I'll say simple calculator multi-stage. Okay, just for our reference. And dot. Let us see what will be the image size. What happened here? Oh, sorry. I did not provide minus t. So the command is wrong. What I missed here is I have to provide minus t because we are tagging the image. So now let us see what will be the size. I'm very sure most of you will be shocked to see this. Let us use the same command called docker head minus 5, and the size has gone down to, do you see it here? Simple calculator multi-stage. What is the size of it? 1.83 MB. Now, can you imagine how many times the size of the application has gone down? So this was the size of simple calculator application that we have created, that is 861 MB. And this is the size of simple calculator multi-stage, that is only 1.83 MB. That means we have reduced it by 800 times. Close to. Am I right? So this is the demonstration that I wanted to show you, and it is really important to understand the concept of multi-stage builds. It is really it is really important to understand the concept of distroless images, because that is the future of containers. The main advantages that you have to talk in interviews is by moving towards multi-stage builds and moving towards distroless images. We not only reduce the size of the image, but we also made sure that the container images that we have, or the containers that we have, are running securely and that are very less vulnerable to the threats, right? So this is the advantage, guys. And now let me show you how to find distroless images. So all that you need to do is you just have to search for distroless images. You will see a GitHub repository for distroless images. Just go there, and what you will see is a bunch for distroless images. Just go there, and what you will see is a bunch of folders here. Let's say I want to find for Java. Just go to the Java folder, and in the readme.md you will have the location of this distroless images. So if you want to replace, like the same example, if you are using a Java application, what you will do is you will go to my Docker file, and finally instead of scratch, what you will do is you will just replace with this distroless images. If you want to use OpenJDK 11, if you want to use OpenJDK 17, you will use this distroless image. And I have also tried that. So because I wanted to show you people in the demo, I also initially played with a Java application, but finally I choose Golang application because it has the biggest advantage. But if you're using a Java application, then again the image size has come down to 200 MB. Here in this case it is slightly more because we have the OpenJDK dependency. But if you're using the Golang application with a very bare minimal scratch, it only has 1.83 MB. So this is the biggest advantage that you are getting with distroless images and multi-stage Docker build. I hope this video was informative, and I hope you learned a lot of things from this video. So if you like this video, click on the like button. If you have any feedback for me, share that in the comment section. And finally, don't forget to subscribe to my channel, Abhishek Virmala.
So as we come to the end of the live session, since we explored today the multi-stage tower, and also did hands-on practical as well. So based on the guidance provided by Abhishek, and yeah, so we used the Git repo, and understand how the image size is reduced. I think you can see in the screen, earlier it ran without splitting the Docker file or without doing multi-stage. The file size, I think 808 for MB is a simple calculator, but it's a core language. Again, we can convert it another programming language as well. So we first I explored the simple calculator without splitting the Docker file, though it's a single file. So the file or the image size could be, or it is 884 MB. But after I explored, after I did split that particular file in the two part, like the base image and the static image, because when it's come to use core language, I think we don't need to the runtime. So core language runtime is a statically typed programming language. So here I used as a image or the distroless image as a scratch. So it's tremendously reduced the file size around. You can see it's for in my case it's 3.94 MB. I think the tutorial, I think it's around a 1.83 MB. Yeah, so it's a huge advantages when we running out the store the memory of the service memory on the make more efficiency when it's come to we use this kind of distorted image or in the multi-stage Docker file or Docker build. So yeah, so this is all about the today's session, and we will explore. Maybe we don't have any session tomorrow Sunday. I'm not sure about tomorrow, but we will have otherwise Monday morning as usual. We will continue. Thank you. And again, if you have any question, please put it. I will reply. Thank you.